All right, let's look at this homework. So, in looking at number 6 from lesson 1, there's probably a reason you're struggling with it. So, when we take the the first difference, so I just did the table vertically instead of horizontally, and I took the first difference of each. So 5 minus 0, 19.5 minus 5, 43.5 minus 19.5, so on and so forth. I made an error right there. $77 minus 43.5 and 120 minus 77. This gets me my first difference. And it's not constant, so I know it's not linear. So I'm going to take the difference of these numbers now to find my second difference. So 14.5 minus 5, 24 minus 14.5, 33.5 minus 24, 43 minus 33.5. And I find that they are all constant. So a constant second difference means that it is going to be a quadratic equation. So that is part A, is that it will be quadratic. Now that I know that, I can figure out the actual equation. So for part B, I don't need the equation. I'll show you how to do it both ways. 4, 6. It's the next number in our table, so I'm just going to work backwards. Whatever number I get here has to be a difference of 9.5 because that's constant. So I'm going to add 9.5 to 43, and I get 52.5. And then working backwards once more, I'm going to add that 52.5 to 120. So that when the velocity is 6, the stopping distance will be 172.5. And that's going to be in feet. So to figure out the quadratic equation, I need to reference the chart that I made on page 2, bottom, to determine what the second difference of a quadratic is equal to. So I see right here, the second difference of a quadratic is equal to 2a. So I know now that 2a equals my second difference, which in this case was 9.5. I know from my table, my c value is 0. And I just have to find that b value. So 2a equals 9.5. When I divide both sides by 2, I know a has a value of 4.75. I know c equals 0. So I'm going to take a coordinate from the table, and I'll use the coordinates 1, 5. And I'm going to put it into my general equation. So y equals, so y is the 5, ax squared, 4.75, that's my a value, times x squared, plus my b value. And I already know my c value is nothing. So 5 equals 4.75 plus b. Subtract 4.75 from both sides, and I get 0.25. So now I have my A value, my B value. I know C is nothing, so my equation is y equals 4.75 x squared plus 0.25x. And that's it, because the C value is 0. The plus 0 is not wrong, but it's not needed. So that is number 6 on page 5. Over to page 20. You said the box method, so I assume you mean the reverse tabular method. So I know my final quotient is going to start with an x squared. So I have a 2x cubed as my top quotient. So looking at number 1 on page 20, I know that 2x cubed divided by 2x is going to leave me with an x squared. So I'm going to have a quadratic solution. So that'll be 3 terms along the top. And I know I'm dividing by a binomial, 2 terms. That's 2x plus 1. I know my final solution is going to be 2x cubed minus 13x squared minus x plus 3. So the ones I know is this has to be 2x cubed, and this has to be 3. In order to get that, this has to be x squared, and this has to be 3. Because 1 times 3 is what's going in this box, and x squared times 2x is what's going in this box. This allows me to complete 2 other boxes, as 3 times 2x is 6x, and 1 times x squared is just x squared. I don't know why that cut out. So there's only the 2 middle boxes I need. And now I have enough information to complete those 2 middle boxes. So in order to add something to 6x to get negative x, I need this to be negative 7x in this box. And if I'm multiplying by 1, then this is negative 7x. As a check, when I multiply negative 7x by 2x, I get negative 14x squared. And when I line these up, I do in fact get negative 13x squared. So this is my final solution of x squared minus 7x plus 3. So let's take a look at number 2. Again, cube divided by a linear x to the first is going to leave me with a quadratic. So I know it's going to be a 3 by 2. I know my 2 is x plus 2. And my solution is 3x cubed plus 4x squared plus 7x plus 22. Working backwards, I know these boxes has to be 22 and 3x cubed. Why is this erasing? Technical errors right now. 3x cubed. So I know on top, in order to multiply something by x to get 3x cubed, this has to be 3x squared. And multiply something by 2 to get 22, this has to be 11. This allows me to two additional numbers of 11x, 11 times x, and 2 times 3x squared is 6x squared. To finish it off, I just have to find the numbers in the middle. I know working backwards, it has to equal 4x. If I have 6x squared, then this has to be negative 2x squared in order for those two diagonally to add to 4x squared. So what multiplied by x gets me negative 2x squared? Well, that's negative 2x. And then I'll check with the negative 2x times 2 to get negative 4x. And 11x minus 4x does in fact get me 7x. So everything checks out, and that becomes my final solution. Three, I'll do the other method, and then I'll see if you can do 4 on your own. So 3, I'm going to do the long division way, x squared minus 4, going into x to the 4th, plus 6x cubed, minus 7x squared, minus 24x, plus 12. Now it should work either way, but I just want to make sure you see each way. So the x squared going into the x to the 4th gives me x squared on top. I'm then going to multiply it by this whole thing and get x to the 4th minus 4x squared. And I'm going to line up like terms and then subtracting both of these. So the x to the 4th now cancel. The 6x cubed is still there. Negative 7 minus negative 4 is negative 7 plus 4, so now I have minus 3x squared. Rinse and repeat. 6x cubed divided by x squared is going to be 6x. Multiply it by everything. I get 6x cubed minus 24x. Let's slide that over so we're lined up. Minus 24x. I'm going to bring this down. And when I subtract, I have negative 3x squared. These are going to cancel. Negative 24 minus negative 24 is plus 24. Those are going to cancel. So I'm going to bring the 12 down. So I have negative 3x squared plus 12. And finally, negative 3x squared divided by x squared is just negative 3. And when I multiply back through, I get negative 3x squared plus 12. And when I subtract, I end up with 0, which is what I want. So x squared plus 6x minus 3 is my solution. This would be a little more complex with the tabular method because you're going to have 5 different terms in those boxes. So every box would contain a unique term. So there'd be no like terms to combine. So it can be done the reverse tabular method or the box method. But typically when dividing by a quadratic long division, and if lining up like terms, makes a little more sense. So I will leave number 4 for you. And you should get, if you have done it correctly, 6x squared plus x minus 3. So you can check yourself on that one, doing either method, to see if you can get that answer. And that'll be it for the homework video. Talk to you soon.